Alright, this video is about how to identify an unknown atomic model. And there's a couple ways to do this. We're going to go about it a couple different ways, so just follow along. Here we have our key giving us the color indicators of what is what. And we can see there are protons and neutrons in the nucleus. We can identify 3 protons. And we see 3 electrons and 4 neutrons. Now, if you recall correctly, when you look at the periodic table, every one of those boxes is an element key. That top number should be what we know as the ape number, which means this number is equal to protons and equal to electrons. So if these are both 3, this number should be 3 at the top in the box. So now I'm going to look at my periodic table, and right here I can identify the ape number 3. The element is lithium. The mass is 7 because that's 0.9. So remember, if it's 5 to 9, the monkey climbs, so it would be 7, the mass number 7. So this is lithium. The mass number is 7. So that's one way to go about it, checking the protons. But let's say you can't really see how many protons there are. So knowing that the ape number is protons are equal to electrons, so if I can count the electrons, then I can also know the number of protons, which means I know the ape number. So let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are 11. So the number of protons should be 11. The atomic number should be 11. So I'm going to check again. Once again, I'm looking for a key that has the ape number 11. That's what I've identified I need to find. So let's look at all our little boxes here. Oh, look, there it is. And it is sodium. And it has a mass of 22.99, which means 5 to 9, the monkey climbs. So we're going to round that to 23. So this is sodium, and the mass number is 23. Alright, so it really isn't very difficult once you understand how to read the periodic table. There is even an easier way to do it. Let's say there are here in this model you have 2 electron orbits or 2 electron shells, right? And you know that you have 1 outermost electron, meaning you have 1 valence electron. Well, if you recall from the periodic table, if you have 2 shells, you have to be in row or period 2. That's row 2, right? Period 2 is row. So that tells you if you're in that period or in that row, you all have 2 shells. So that must be 1 in that row. And 1 valence electron means you need to be in group 1, because group 1 had 1A or 1 valence electron. So remember, valence electron, outermost electron. So let's check our theory here. So period 2, right? Our period, row 2. And group 1, here's 1A, meaning 1 valence electron. Alright, so where the 2 meet, lo and behold, that's another way of identifying an unknown atomic model. Now let's try this one more time. We already know it's sodium, but let's try it this other way. So we have 1, 2, 3 shells, meaning it is in period 3. Alright? And we said it had 1 outermost electron, so it's got 1 valence electron, meaning it's got to be in group 1A or group 1 with 1 valence electron. So let's look. we say 3 shells, so this is going to be in this row, period 3. Group 1, because of 1 valence electron, and yes, there it is, another way to identify. Make sure when you're looking at these periods that you understand group 2 goes all the way across, 3 goes all the way across. Only 4 includes in these transition metals, okay? So you read it all the way across, even 1. All the way across. Only 2 elements in 1 are hydrogen and helium, okay?